I'm going to call this meeting to order. It's a meeting of the Engineering Equipment Committee of the Vallecitos Water District for Monday, February 8th, 2021 at 3 p.m. via teleconference. I'll hand it over to the general manager.
All right, just for the record, we have no members of the public in attendance today, and we have 3 items. So the first 2 are continuing dialogues about our asset management program. So I believe Susan will be covering those. And then we have an update on the, well, actually it's a proposed amendment for the San Marcos Interceptor Sewer construction management project or contract. So with that, James, did you want to kick anything off on the asset management?
Yeah, just briefly before Susan takes over. So we're going to be providing the committee and then in the future, the whole board, different presentations, kind of taking the committee and the board along a journey of what we're doing for asset management. So you're going to see kind of a common theme. There's several different aspects of it. Susan, we're really going to concentrate on one at a time and then kind of go over the whole program. There'll be future workshops that we will need to get management, staff, and then of course the board involved in as we go along. But this is really, now we're starting to move forward, and a lot of the items that we've been kind of talking to the committee and the board about in the past, they're starting to become a reality here. So it's time to kind of get into a deeper dive. The second item will actually kind of be an action item 2, which will kind of go along with the first item, but I don't want to take too much of Susan's presentation away. So Susan, why don't you take over?
You're muted.
You're on mute. Thank you, James. Directors, thank you for giving me this opportunity to share with you where we are on the asset management program, and in particular, the condition assessments. I'm going to share my screen to start the PowerPoint. There we go. And from beginning. All right, there we are. Okay. So asset management, this screen and these different aspects of asset management may be beginning to look familiar to you as we continue down this path of learning about what asset management is and what it can do for the district. And as you can see here, I've circled the item condition, because that's what we're going to be focusing on today, is understanding how the condition of the assets is so critical to really implementing an asset management program and being able to really invest our funds most effectively. It's critical that we understand the condition of all of the equipment as well as the underground infrastructure, which is challenging to get condition assessments on. And that's what we're going to be talking to you a bit about today. So again, with the asset management program, I just wanted to give you a bit of an update on where we are for the asset management program. I think we looked at this slide last time we were together, but I've made some changes on it to let you know the progress that we've made on certain aspects of these, particularly since this slide was first put together a year ago. So what you can see here is these are the 4 really aspects of the progression of asset management and what steps we need to go through to implement it and then get it into a regular way of doing business here at the district. So where we were is the bar charts here that don't have any added arrows on them. That's where we stood about a year ago. And again, this was kind of based on my assessment working with the district engineer, James, and others in the district, really trying to understand what status we were at for all of these items that really are the key aspects of the asset management program. So in this last year, we've made some great progress with regards to condition assessment. It's really been a big focus getting that started. We've also, as you can see, so we've really gone from about a 20-25% level of progression, if you will, for condition assessments, getting a consultants in, to where we are today. And after the approval of last time we approved the land outfall condition assessment, this meeting and then the board meeting, hopefully we'll be getting a recommendation to approve further condition assessments. Really takes us up to about a 60% success rate of moving forward with a lot of the condition assessments, not necessarily completing all of them, but getting them on our agenda here. Additionally, we've made great progress with bringing together the data between GIS and CMMS. So that's our maintenance data and our mapping data. Whoops, pardon me. How do I go back? Bringing those data together, getting those two things talking and sharing information. So we've made some great progress there. Additionally, we've made good progress. We already were doing well with business process mapping, but we've been adding up to about 75% completeness of documenting our business processes, documenting how things are done. And that's very helpful for training, et cetera, for staff. And moving along, you can see here business risk exposure. We've moved that up from where it was before at about 15 up to about 35%. And again, this is, as I'll talk to you about, a key component information coming from the condition assessments. And moving along, let me move there we go. Moving along to the far right here, again, with regards to training staff and looking at data quality, we've made some real strides over this last year to get staff well aware of what asset management is, using the systems that we're putting in place, and it goes along with the training that we're doing for the board as well, and understanding what asset management is.
Yep.
So
and really quick, just to add to that. So in our presentations for asset management, whether they come quarterly or as items come up, as we go down kind of the different aspects of it, we plan on bringing the committee the same chart and to show the progression each time. So, in case there's any questions, you could see what staff's been working on and how we're progressing. As you can see, there's a lot of different things that we're working on at the same time, and we're all moving them forward, some of them faster than others.
Yeah. So back to what we're going to focus on today, which is the condition assessment. Just wanted to give a brief overview for you about the infrastructure that we have in the ground. So as you well know, the district dates back to the 1950s, as do some of our pipes. So we have about 265 miles of sewer pipe and 357 miles of water pipe. And you can see from this chart, this is just showing the age distribution for the given material types that we have in the ground currently. You can clearly see how we, in our early years of the district, a lot of the construction was AC. And then we had this big period here. This is around the 2000s, where we were putting in the ductile iron pipe. As we know, that was really considered to be an excellent material, but as we've come to discover, there's some challenges with it. And then more recently, we have discontinued the ductile iron for the most part and are moving into the PVC type of pipe for the system. And you can see here, we still have quite a few miles of the AC back in the over 50 years old. So it's still performing well in the ground, or performing at least to the point where it's still there. But this just gives you an idea of what type of materials we have in the ground. Okay, now moving on for what these conditions will do, condition assessments will do for us. Really, they're about giving us information, giving us knowledge so that we can make the best decisions about what needs to be repaired, rehabbed, or full replacement. For sewer pipe, it's a lot easier to understand what's going on with it. You do the CCTV work. The district is CCTVing all of our collection infrastructure regularly, and using that information to build maintenance planning and CIP work for replacements. It's clearly it's easier to CCTV on a sewer pipe than it is for water. But for the water pipelines, we're in the process of being in a phased multi-year condition assessment program. This started with the work that we had done with VNA Consulting, where they looked at different methodologies that can be used for condition assessments and what's best for the different types of infrastructure, different conditions that we have in the district. They had done a full assessment of and reviewed all of the different types of assessment technologies that are there out in the industry, and gave recommendations for what's most appropriate. And then for the ductile iron, we did a risk prioritization model, which I will explain a bit more on the next slides, what that has done for us. So let me launch into that. Here is, I hope you can see this. This is an example of the information that we received back from VNA, looking at these different technologies that are available to do condition assessments. You know, they all have their pros and cons, just like anything. They all have different costs. And then you really have to look at what's the cost benefit for the different technologies. Some of them are internal, some of them require you to dig up the pipes, and some don't require that. So there's a real variation. We have this report. This is just one screen from a multi-page report that provided us with all of this detail on what were technologies that we really need to look at for assessing the condition of our water pipes. As you can see here, there's different categories. The different technologies provide different pieces of information to sort of build out your knowledge base on what's going on with your pipes. So it's multifaceted, and different tools give you different bits and pieces of the puzzle to help really get a good picture of what's going on with the pipelines. So what about the condition of our pipelines? So business risk exposure is what we're going to use to really determine what the priority pipes are as we go forward. And it's important that you do this kind of a risk exposure to understand that not all failures are due to something as simple as age. The pipe condition has a lot to do with the performance of a pipe. So this chart here, what it's showing you is the two bars together are different material types for the pipes, as we showed earlier. And also shows the average age. So the gray line is showing you the percentage of pipes, I'm sorry, the percentage of breaks since 2007 versus the percentage of mileage of this particular material in the ground. So it's displaying to you which pipes are having failures, more more common failures versus the total mileage that we have in the ground. So it's not correlated to the amount of pipe that's in there, nor is it necessarily correlated, as we've said, to the age of the pipe. So ductile iron, average age of 17 years, makes up 49% of our breaks for the last, since 2007. So the last 14 years or so. Not counting those breaks that might have been like something that was a contractor hit. I think that's the one thing we don't, just like an actual direct contractor hit. And yet ductile iron is only 28% of our inventory. So you can see here, it's just to show you that you can't always look at one factor when you're trying to determine replacement, rehab activities to take. Things that contribute, again, are just the original construction. We know that we have a challenge with the dry utilities going in around our ductile iron pipes that has affected the integrity of the lining, the surrounding, around the pipes. to keep it from getting corroded. Even sometimes when we have a fire hydrant hit or something, there's some operational impacts that may be contributing to breaks.
Yeah, and just to kind of add with this, if you look at this chart, the two areas where the gray line is significantly larger than the in my screen, it's kind of an orangey line, which is the ductile iron and the older steel. It's a different type of 12 gauge steel. Both those are within what we're directly looking at both those materials for a multi-year condition assessment. The steel being much less as far as linear footage and kind of on its own track, while the ductile iron being, faceted or phased in over many years.
Question, Susan?
Yes.
And you're gonna, I think you should do this at the board meeting as well, but what is ACP? What is that? Pipe.
Asbestos cement.
Yep.
Asbestos cement pipe?
Yep.
Okay, now that's what I thought, but do we have, is somebody gonna go, what do you mean asbestos? Oh my gosh, are we gonna all die here from lung cancer, whatever? I don't think that's the case, but is it, how do we tell the public that we have asbestos cement pipe and it's not hazardous?
So, Director, asbestos is hazardous if you inhale it. It's actually not hazardous for drinking water pipes, and majority of the pipe material for many years was the ACP. The only reason that it really got outlawed is because in the manufacturing process of the ACP, people actually inhaled it, and of course that causes cancer. So you can't manufacture ACP. But as far as the pipe material being used for water, when it's not inhaled, it's fairly inert and it's harmless.
Yeah, and that's all true, but you're going to get members of the public when they hear the word asbestos, they're going to associate it with health risk. So it would probably be in our best interest not to go out and use the word asbestos every time we talk about pipe materials.
Yeah. The other one is CMLC. Is that concrete metal something? What's that?
Yes, concrete mortar and lime coated. That's the newer steel pipe.
Okay, and then the PCCP.
That's it's
Yeah.
Ryan, you may know the actual term, but it's basically older wrap steel. It's basically super thin with basically a rebar that I always call it circumferentially wrapped pipe or post tension pipe, but it's basically like thin as a tin can.
Yeah, it stands for pre-stressed concrete cylinder steel.
There you go.
Oh, there we go.
That's what I was gonna say.
All right.
Yep. Okay.
All right. Well, yeah, that gives me something to think about.
Yeah, and you can see we don't have very much of it really. So I think there's just a few sticks of it here and there. Probably, yeah, slated to be replaced. Just certainly because its age is it's clearly probably past its useful life just strictly on its age.
Hey, Susan, real quickly, so if you can go back, on the ductile iron pipe, so you're showing an average age. If you just analyze the ductile iron pipe, is there any correlation with failure and age? Or does it seem to be kind of all over the place within that category?
I don't think the age is showing itself to be a determining factor, particularly because as we look back here, it really was, it's a very focused period of time that it was installed. So it doesn't allow for a lot of differentiation in how it's performing.
Okay.
And also, Glenn, with that, the not all of them, but a vast, maybe I don't know if it's the majority, but a big chunk of them has been user error due to dry utility crossings.
Right.
Which we don't know about until later, so they'll impact the wrap and then the corrosion will slowly occur.
Yeah, that was kind of what I was getting at. So the user error, the getting nicked, happens during installation. And I don't know if we are starting to see the data that tells us how quickly does that clock tick to failure once it's nicked. So, but probably too fine a detail to talk about in today's meeting, but we'll talk more about it offline.
Yeah, but the soil corrosivity, as we'll talk about in a minute, is something that we'll be looking at, which would contribute to how quickly that corrosion occurs. Okay. So the business risk.
Susan, I
Yes.
have a question before you move on. I'm wondering on the CML and C pipe, do we have cathodic protection systems on that steel pipe?
Yeah, Director Elapart, we sure do. So we have mainly or it's almost all passive systems with anodes and test stations. But on our CMLC and any pipe over 16-inch or 16-inch diameter larger, we have anode systems, passive systems installed. On the CMLC, we definitely have those also, and almost not all of our CMLC, but almost all of our CMLC is our larger diameter. And for us, larger diameter starts at 16.
Okay. And on the tar wrap steel, is that just that one line out in Twin Oaks Valley?
No, the tar wrap steel is primarily the line that we call the Trace Amigos line on the north end of the district. And that's the board, you guys may recall, we're replacing almost all of it.
Right.
And Ryan, are we replacing all that tar wrap steel? Is there any section that's being left? You're on mute.
No, we are taking out all that tar wrap steel in its entirety to the junction where it turns to cement mortar line and coated steel.
Okay. So we're hoping when the Trace Amigo job is done, the amount of tar wrap steel will pretty much be gone.
Okay.
So that's all. It's all the irrigation pipe left over from when we inherited when the district first formed. So.
Is that cement mortar lined?
I don't even know if it is, to be honest.
Or maybe it's epoxy. Okay, thanks.
You know, Ryan?
The tar wrap steel, or which one are you talking about?
The tar wrap. What's the interior coating?
Oh, I don't know if it even has one. I'm not certain on that, but we will determine soon enough.
I was just curious. Yeah, you'll find out when you tear it all out.
Yeah.
Mm-hmm. It's very old. I know that.
Okay, thanks.
You're welcome. So the business risk exposure is a calculated score that is made up of the likelihood of failure and the consequence of failure. The likelihood of failure is directly related to the condition of the pipe along with other factors, which I'll show you in a minute. And then I think we talked about last time as well, the consequence of failure, which is not always something that can be changed. It's based on the location of the pipe or maybe the customers it's serving. It may change because of the customer base, but is not usually, consequence isn't normally something that the district has a lot of control over as far as ability to modify it, but it certainly is critical to understanding then what different pipelines, what their risk is to the organization and to our customers. So
I may interrupt real quick. I just want to let the directors know that Mr. Hunsaker has joined the meeting. So just for your information. Go ahead, Susan.
Thank you. So the likelihood of failure, again, the condition, this is the VNA had come up with the district's input, the factors that would be used to determine the likelihood of failure score. And as you can see, the condition makes up 25% of that calculation in the weighting. So it's critical that we have a good understanding of the condition of the pipe. Soil corrosivity plays in. Again, the dry utilities is another factor, as we've noted, because we realize that that's impacting us. That's information that we can gather just from doing GIS analyses. The break history, again, that's information data that we have. Break history and most recent break, that's data that's available to us. The hydraulic fluctuations, again, data that's available to us. And the installation year is also a known piece of information. So as you can see, getting a good understanding of an asset's likelihood of failure is not only because of the weighting, but just the fact that it's not easily known what a condition of the asset is unless you perform these condition assessments to determine that. So just wanted to give you a quick picture of the condition assessments that we will be undertaking or that we've already started. Director Elitharp, you just asked about some of the steel pipelines. As we mentioned, that the one area is already being replaced, but there's this small area here installed in 1956 that is a critical infrastructure, critical area, and we will be doing a condition assessment of this particular area, ideally summer and fall of this year, utilizing either smart ball technology, HydroSnake, which is similar to the technology, the Pika technology that was done at High Point. They used a slightly different variation of that tool that's for larger pipelines. So we're looking at using HydroSnake for this particular area that's a very high consequence of failure. So that's something we'll be coming to you with here in the near future.
And just to add to that, it's a high consequence of failure in this area for two reasons. First off, that dashed area is where we're talking about, kind of in the middle of your page. If you move your mouse over to that and kind of highlight it, that area goes between homes and an easement. It's an old easement that was there. There's houses on both sides. There's semi-permanent structures right adjacent or right on the easement itself. And so a break in that area would cause significant property damage, but also breaking that pipe cuts off our lifeline supply. So this pipe, going out to the east, goes all the way into Escondido and hooks to the second aqueduct. So, and it's what we used to call the Vallecitos 2 connection, but now it's called the Vallecitos 11. And when the aqueduct gets shut down, they don't shut down both portable sides. So when our main supply that we connect to CWA on the basically within San Marcos and on the west side of our system is shut down, the only supply that's a general aqueduct connection is this connection that we get. So it's an important connection for our water operation. So so high consequence of failure is not only damage, is also how critical it is to our infrastructure.
And certainly due to its age as well, that we need to understand that condition. So that's something that we'll be coming to you with. It's in the budget already for this year and for, I think, a year after that as well. The next one that we have, which we talked about last month, is the Land Outfall West condition assessment. We are moving forward with that, and that's to do the CCTV and sonar of that condition, the Land Outfall West between El Norte Parkway into the treatment facilities in Carlsbad and Sena. So that one's underway, hoping to get information from them by the end of this fiscal year. And this is one of the sonar type device that will be inserted in through manholes to determine the condition of that pipeline. And the last one I wanted to talk about, and is actually going to then take us into the next agenda item, is the ductile iron pipeline condition assessment. This is a continuation of the work that we had done with VNA, and we are going to be doing a leak detection for determining where there might be a high likelihood of failure. And we can use that to determine where we may need to do additional assessments. So we'll be looking at we'll be inserting a device that will do some listening for leaks, and will then direct us to do further investigation. Also, we'll be doing soil corrosivity analysis, as I had mentioned, to see what the status of the soil that's in this area. And then once we get this information, we would follow up with additional technologies to really get a good idea of what is happening with a tool similar to HydroSnake. If you recall, that allows us to understand the remaining wall thickness of those pipelines without having to do actually digging up of the pipeline and taking a look at it. So this is the next item that we're going to be discussing. So I'm going to go ahead and launch into that.
Well, really quick, does the members of the committee have any questions on our asset management program, or if specifically the pipeline condition program that we're going to start moving forward with?
No, I don't.
No?
And James, I would like to add before we move on, and I feel incumbent to say this every time we talk about asset management. The goal of asset management is to minimize our life cycle costs. It's to take a look at the long term. So, but what you're going to see up front is a lot of expenditures of monies to figure out what we have. So initially, I think we're going to see a large expenditure, not just in the condition assessment and the planning and all that, but as we look at our pipes, we're going to see more and more problems. So we're going to be going in and repairing things. The hope is that by catching the problems early, that the cost of repairs will be significantly less than they would otherwise have been if we hadn't identified them and we found out the hard way, right? By a water line break in the middle of a major intersection or something like that. So I just want to keep in mind all along that you're going to be asked to be approving not just the committee, but the full board. We're going to be asking for a commitment of a lot of expenditure of funds to make sure we have a better idea of what we have to help us lower the costs in the long run. So that's what I wanted to say. And I did want to point out that Mr. Hunsaker does have his hand raised. And before we move on to the second item, it'd probably be an appropriate time to ask Mr. Hunsaker if that's okay with you, Director Ellithorpe.
Yeah, before we do that, I had one related question to what you were just talking about. And I think I've asked this before, so I apologize if I've forgotten the answer, but do we have a long-range financing plan yet that has determined how much is fiscally sustainable to spend on an annual basis for these activities and including replacement projects?
Go ahead,
Or
James.
is that something Wes is working on now?
So actually, I don't know if you've asked that question, but it is a great segue. So one of the final outcomes from the finance side for the asset management plan, this is after we get the full plan implemented, not implemented, but get a consultant on board to actually go through. Basically, it's a asset management master plan, so to speak. One of the final products of that will be a replacement schedule for our existing infrastructure, which we do not have at this point. That's going to be utilized as one of the informational items, and it's going to be a very data-based analytical item for Wes to use along with whatever items that he needs to use from a finance side to figure out the correct reserve levels. So are our reserves too high? Are our reserves too low? We may find out that our reserves are grossly too low to replace $400 or $500 million worth of infrastructure in the next 75 years. But then that will start having more discussions on reserve policies, how we move forward, and then also how much do we do on the asset replacement? So these are the workshops that are still forthcoming, and the discussions that staff will need to have both with management and the committee and the board.
Yeah, so we do some long-range financial planning, but as James was saying, we need to really integrate the findings of our asset management and condition assessment into that. Right now, when we set our reserve levels, we're looking at the capital expenditures anticipated anywhere between 3 and 10 years or 3 and 8 years, depending if you're talking water or wastewater. But a lot of that is based on like straight line depreciations. As we start doing condition assessment and asset management, we'll get a better feel for is straight line the appropriate tool to use, or do we need to accelerate the expenditures? So we have a long way to go, but I think the asset management information is going to help us get there.
Okay, great. Thank you.
Can I call on Mr. Hunsaker now?
Yes, let's do that.
Okay. Mr. Hunsaker, go ahead.
I understand that this is water distribution, so it's not talking at all about sewer lines at that point. Is that correct?
Well, we're
No.
we're focusing on the water right now, but we do have a wastewater asset management plan as well.
Okay, so there's no Tektite water distribution lines?
No,
No, Mr. Hunsaker, we do not have any Techite water distribution.
Okay. And lastly, in your risk assessment, it seems to be at odds with the discussion of materials. The discussion points very directly to the ductile pipe issues, but those are some of the youngest lines. So why is there doesn't seem to be a correlation between the rating factors and the life of the pipe? Thank you.
I could start on that, and Susan, you could correct me or add to it. So the ductile iron pipe is fairly new pipe, and it's actually a very robust pipe, but most, or at least a big chunk of the failures that we've seen in ductile iron has been due to dry utility crossings hitting and damaging the protective coatings, whether it's the bag or the actual pipe itself, leaving the pipe exposed, and then over time it corrodes. So there is a dry utility, and then the condition assessment, specifically the program or the majority of the program is specifically for ductile iron, because the ductile iron pipe itself, if it's in good condition, has a very long useful life. If we could find these point failure spots from human errors from the past, then hopefully we could assess those and repair those before they become breaks. Then the remainder of the ductile iron can continue to be a very long useful life asset. Susan, would you like to add anything else to that?
I just would like to point out that this particular, the likelihood of failure calculation that was shown here is specific to the ductile iron pipe. I know it doesn't say that on the screen, but that is, first of all, one reason why you don't see material type as a factor in the calculation, because it is solely for the ductile iron pipe. And the reason at this point that we're doing it by material type is that the factors would change based on the material type and how we're implementing the calculation. So for example, you can see here, we don't have a very broad range of age for the installation year. You know, we're only going back, 25 years. And that correlates with the age of our ductile iron and the installation periods for ductile iron. So as you look at this, it's just important to keep that in mind, that this is focused solely on the ductile iron calculation. And so, and ultimately then when we do the asset management plan, all of that, the business risk exposures for the different material types, et cetera, would all be brought together to help form the requirements for replacing the assets. And as you asked, laying out what the financial requirements are for that.
Okay, I think are we ready to go to item 2, Director Elizabeth?
Yes.
Okay, thank you. Susan, you'll be taking that too, I assume?
Yes, yes. So I will just leave this up. I wanted to just direct your attention to then the staff report. So we're coming to you today to get a recommendation of approval to be taken to the board to issue a contract for V&A Consulting to perform the ductile iron condition assessment pilot project. So this is a small focused assessment of the area in the staff report that you can see. It's an area of 25 miles that was identified through applying that risk assessment that we just discussed, applying it across the district, assigning 25 areas and rating them based on the risk area. It's considered a cluster. And then with that, we identified the areas 8, 9, and 10 are some of the highest risk. And what we, with VNA, what we're going to do is apply a couple of those technologies that we just discussed. Specifically, what we're going to do is a leak detection effort to have sounding equipment go in and provide us with leak detection. Although leaks are not a major issue in the district, what we want to understand is, does this sounding equipment provide us some information that can be used to correlate with the level of quality of the pipe that we have. Additionally, there we'll also have VNA oversight on doing corrosion, soil corrosivity and resistivity testing. And again, that's to determine how correlated those pieces of information are to help us understand the condition of the pipes. Certainly this area, this is the San Elijo Hills area. We know, that it's had a high break history considering its age. And this effort with VNA will give us some good information and help us understand if the technologies that they're recommending will give us valuable information. As I mentioned, follow on from this as additional work, we'll be looking then at doing some type of the hydrosnake or something else. So again, at this point where we're just now getting a look inside our ductile iron pipes, we're looking at really trying to understand what the most cost-effective technologies are out there so that we'll be able to apply that across the district and really get an idea of the condition of the ductile iron pipe. So what we're asking for is your approval on a contract that's based on the as-needed contracts with VNA in the amount of $70,402. Approximately 75% of that is for the actual direct inspection work, the leak detection and the soil work. And then the remaining 25% is for project management and a technical memorandum from VNA, analyzing both the findings and giving us recommendations on the value of this sort of technology being applied to our infrastructure.
And if I can clarify, so we're not looking for the committee's approval because it's going to go to the board. What we're looking to, you may recall the conversation that we'd like to have the committees making recommendations to the board. So what we're looking for is to see if the committee can support staff's recommendation so that when we go to the board, we can say staff recommends and the committee recommends the board approve this agreement with VNA.
Okay, do you need a motion and a vote to do the recommendation to the board?
I don't think we need anything that official. I don't want you to be surprised when you read the final staff report and it says the engineering committee supports it. So if you're in opposition to it, it'd be nice to hear that now. If you're not, I don't think we need a formal action per se. But
Okay. All right, I'll ask Director Hernandez if he would support recommending this to the board.
Oh, yes, absolutely.
And I as well.
okay, good.
Thank you.
Thank you.
Thank you, Susan.
All right, so I think we're on to item 3. That's the San Marcos Interceptor Construction Management Amendment. And Ryan, are you going to take that one?
Yes, I am. Thank you, General Manager Prom. I'm just going to share my screen. Okay, you should all see my screen now.
Yep.
As you're all aware, the San Marcos Interceptor Phase 2 construction has been ongoing since the summer of 2020. Construction progress is nearing 60% complete. We're over 50% of the way there. Crews have recently installed the micro tunnel undercrossing of the triple box concrete culvert at Pacific Street and San Marcos Boulevard. Currently, they are stacking the manhole that's right here that accepts the mobile home park that's right here. Sewer lateral ties into the interceptor at this point. And they're going to continue to march east to an existing manhole which they've already installed at the Tamarisk intersection. The Tamarisk Lane is already complete, and the Creekside up to McMar is also complete. So the last leg of the project will be here in the Creekside to Via Veracruz, between McMar and Via Veracruz. As you're aware, phase 2 is the final phase of the interceptor improvements, which have been ongoing in construction since the early 2000s. This project completes essentially 30 years in the making of the most sizable gravity sewer, trunk sewer project the district has put on CIP. The manhole number 1 at Pacific Street is the furthest west reaching terminus of the interceptor. And on board throughout this whole process thus far, Valley-CM, which was originally awarded the contract by the board back on June 17th, 2020. Their initial contract value was $493,614 to provide construction management, inspection services, and also general project coordination, geotechnical engineering services with soils testing, and interfacing with the city of San Marcos on traffic control permitting and other requirements. Overall, Valley-CM has been a very good partner in this project. They based their original scope of work on a 10-month construction schedule. And early on in the project, San Marcos Boulevard, we discovered a lot of unforeseen underground utilities, which threw a wrench at our original design, our final design. So the district was forced to initiate a redesign of the sewer alignment in San Marcos Boulevard, including the microtunnel underneath that triple box culvert. The process of redesign and approvals, review, took about 2 months. So the project was delayed a little over 2 months early on, and we've been essentially back on track ever since then. But this delay, of course, added additional work to Valley-CM's scope. And additionally, with traffic permitting and coordination with the city of San Marcos, it was in the contractor's best interest to work nights for a long time on San Marcos Boulevard. So they were actually pulling double shifts. They're working days and nights every day for a good 3 weeks or so. It was to the best interest of the project to do that. It actually expedited the schedule and cleared us of some imminent hurdles that we had to cross at one point or another. Due to these unforeseen delays and additional shifts of work, staff requested Amendment 1 proposal from Valley-CM on January 24th. Staff reviewed the amendment for content and completeness, for additional inspections, testing, and construction management services. Valley-CM's time and materials not to exceed fee in Amendment number 1 is $142,560, to which Valley-CM will perform the remaining CM and inspections services for the project, including environmental, biology, monitoring, and archaeological services as well, which I failed to mention earlier. The project, as you know, is already funded in the 2021 budget. Staff plans to come to the board on the February 17th meeting with this item, and purpose similar to what Glenn mentioned earlier was we're seeking the, I guess, informal approval of the committee members on this item when they see it on the 17th. And with that, I'll take any questions you may have.
Director Ellithorpe, if I can, before the committee members discuss it, maybe some clarification for Ryan. So this amendment accounts for the delay impacts on the CM contract. Are the cost impacts with the construction delays included in change order number 1? Or are there going to be further adjustments because of the delay in the construction?
Well, that's a good question. I didn't really mention change order one, but change order one included all the construction extras that were initiated as part of that redesign effort, including some additional PCOs for little things that were discovered on Tamarisk Lane and in other areas of the project. So in total, change order one hasn't crossed our 5% contingency threshold yet. We had about $315,000 in that contingency. Change order one was approximately 260,000. And we have about 55,000 remaining in that contingency. So that's why the board hasn't seen that yet. The biggest risk to the project going forward, as I mentioned, we will finish the project on this leg in the creek with a tie-in just west of Via Veracruz. And as you may or may not know, when it's subject to heavy rains, it can get very muddy down there. It's got a very high groundwater table. So dewatering the sewer trench has already proved to be a slight issue in the past. Luckily, they didn't install the trunk sewer there at that time. But coming back there, that depending on how much rains we see and things of that nature, and coordinating with the city of San Marcos's Creekside project as well, that, in my opinion, is the biggest project risk going forward.
So today, change order one, which is initiated already through staff per our policy, covers us for all the changes to date, which includes all the utility issues that we ran into in San Marcos Boulevard. So this is now just cleaning up the other side of the house, which is the construction managers. Now that his time has been booked, we know the impacts. This is the amendment to make the construction manager whole on the additional scope work that wasn't in the original scope.
Thanks, guys.
Okay, so really the only remaining risk is that section in Tamarisk. And I assume that's going to take place here over the next couple months of the winter season.
The project completion with change order one is currently at June 21st. And in all likelihood, that's more than enough time to do this work, to finish up San Marcos Boulevard, and then to mobilize to the creek and to finish that last leg. If all goes well, they will finish early. But there's a lot of unknowns around the rain season that's yet to come. So
when do you anticipate they'll be in the creek area?
They'll be in the creek starting in about anywhere between 3-4 weeks, probably from today.
Okay. So yeah,
they're going to finish up San Marcos Boulevard over the next 3 weeks.
Okay. Any questions from Director Hernandez?
Nope. I keep driving out of the way to keep out of their way.
Okay.
Appreciate that.
So I would say at this time, when we take this to the board, we're not asking for any additional contingency, correct, James?
Yes.
We'll track it, and we don't have a lot left. If you're looking at page 6 of the staff report, we have about a little less than $56,000 left of contingency, which isn't a lot when you have a big diameter sewer pipe running along a creek in the rainy season. But
it's about worth about one change order, probably.
yeah, it's
Pretty
not
much.
So if we have a change order in the future, then we'll have to go back to the board for additional. But at this point in time, we're kind of holding the line on the budget that we have.
And really today we're asking the committee for committee support on staff's recommendation to the board for this amendment.
All right. Well, you got my support,
Mine
Director
as
Hernandez.
well.
Okay.
Okay,
Thank you.
Thank you.
thank you.
Thank you.
I don't see any, Mr. Hunsaker doesn't have his hand raised, so I think that's all from the public then.
Okay.
And that's all staff had today.
Great. Good meeting. A lot of good information.
So we'll be meeting again in March. I forget the exact date, but we agreed. I think we sent out a list of the meeting dates, but if there's anything that either of the committee members would like to see presented in March, please let us know as soon as possible. Otherwise, staff will put together the agenda.
All right.
All right.
Thank you.
Thank you all.
All right.
you.
Thank you.
Thank you.
Bye-bye.
Take care.